welcome to my YouTube channel. So here today we are going to be looking at mathematical induction. So we are going to be solving all these problems, question 1 to 6. So after this, you will never have any challenge dealing with this type of mathematical induction. So now, what are we going to be looking at? We are going to be looking at the first thing, which we are going to call the basic step. The basic step just involves you to letting n be equal to any number. It could be 1, it could be n is equal to 2, anything that you want, as long as you equate it and find out if it will give you an answer. So now let's after doing the basic step, you are now going to do the inductive step. Under the inductive step, this is where you set your n to be equal to your k, like that. Then last but not the least, you are going to have the inductive hypothesis. So the inductive hypothesis is the one that more like deals with you dealing with the next term and find out if your formula will work. This is where you let your n be equal to k plus 1. But this one, it is not direct. This one, you are going to be doing this by adding. So you are going to do this by adding, then compare with the original equation by substituting. It will make sense as we look at the question. So let us begin. So let's say you have this question. We have question 1, which says that use mathematical induction to prove that the given formulas are valid for any positive integer n. So we want to see whether the formula is correct for the integer. Now let's say we let our n. So we are going to say, let me copy this and put it down here. So if we do that, what we are going to have is, we have a 1, we have plus 3, we have plus 5, plus we have the dots plus the 2n minus 1 should be equal to, we have n squared. Then what you are going to do is that you are going to deal with the basic step. So the basic step, you are going to let your n be equal to 1. So where 1 would be more like your first term, like that. So what we are going to have is, if you put 1 where n is, we are going to have our n squared. N squared will be equal to 1 squared, which will be equal to 1, which is the term that is here. Now let's say if you set your n be equal to 2, this is going to give you your n squared is equal to, we are going to have our 2 squared, which will be equal to 4. But 4, where is 4? 4 is 3 plus our 3 plus 1 plus our 3 is going to give us 4. Let's try our n is equal to position 3. So n is equal to 3 will give us a value that will be equivalent. It's just that this is the example, but I'm not going to be doing this throughout. But since this is the first example, I want to give you a picture of what we mean. If n is equal to 3, that means to say we are looking at from the first position to the 5th position. This will give me where n is, n squared will be equal to 3 squared, which will be equal to 9. Where is 9? So if you add, you are going to have your 1 plus 3 is 4 plus 5, that will be your 9. That's how come we have that. So this formula works. Now, you cannot necessarily determine how much of it is true in terms of how far can the formula work as you continue. So that is where mathematical induction comes into play. So we have seen that it is working like that. It is working. So meaning to say it is working, but we cannot continue applying where we set n is equal to 4, n is equal to 5. We need mathematical induction. So now, what are we going to be doing? So under the mathematical induction, we are going to say, under the mathematical induction, what we are going to say is that, so this is how now you answer. So you are going to begin your basic step. So basic step, you are going to set your n to be equal to your 1. For the equation that says that you have your 1 plus your 3 plus your 5 plus your dots plus 5n minus 1, then you have your should be equal to we are going to have our n squared. You are going to compare. The first position is n is equal to 1, like that. From here you are going to have your n squared will be equal to 1. Since n is equal to 1, then we have squared, so this is going to give us 1, like that. Now if it has given us 1, that means to say it is true for n is equal to 1. So after doing that, since this one is the same as n squared, that means it is true. Then what are we going to do? The next step that we are going to do is we are going to say inductive step. Inductive step is just you basically adding or rather setting n to be equal to k. So after doing that, what are we going to have? So that means to say we are going to have 1 plus our 3 plus our 5 plus our dots plus our 2n minus 1. This is going to give us a value that is equivalent to, we have where there is so if we set n is equal to k, that means to say where there is k, or where there is n we put k, then should be equal to, we have our k squared, like that. So if this is the case, what are we going to do now? So this is the inductive step. Then we are going to say, okay, so on inductive step, let's say we are just going to, these are part of the marks. Assume that it is true for n is equal to k, so that we can be able to put where n is, we are going to put k, like that. Then after doing that, now this is true because already if it is true for any value of n, such as n is equal to 1, it means it can be true for n is equal to k, where k can represent any number. So after doing that, what we are now going to say, the next step is that we need to show that it is true for n is equal to k plus 1. So now for this one, you don't replace. So you are going to do this by adding. So how do you add this? So n is equal to k plus 1. So you are going to get your value. You are going to get your value, which is your 1 plus your 3 plus your 5 plus your dots. Then you have your 2. Then here, what we have is this. So we are going to say k minus 1, like that. Then you are adding plus. You are adding where n is equal to k plus 1. So you are going to put it there by saying the last term was 2. So remember, the last term was this 2n minus 1. So where n is, you are going to put k plus 1. So we are going to have our 2. Where n is, we are going to put k plus 1. Then you have minus 1 should be equal to, you have on this other side, you have your k squared. You maintain it. So we are going to say k squared, like that. So this term here, adding it on both sides. Now remember, you are adding k plus 1. Now you are not just adding k plus 1. No. You are adding it in such a way that you are going to look at your last term. It was 2. So if you look here, 2n minus 1. This is what you are adding. But where there is n, you are going to put your k plus 1 minus 1, like that. So in other words, you are adding this on both sides. This one on both sides, like that. So it will make sense as we solve many problems. It will make sense. So what we are going to have is that when we take this, we are going to reduce it, and it will be equal to your k. So when we do this, there is no need for us to repeat this side, but let's repeat one time. 1 plus 3 plus 5 plus dots 2k minus 1 plus 2k by 2 by k, it will be 2k plus our 2 minus 1 will be equal to k squared plus 2 by k, it will be 2k plus our 2 minus 1 should be equal to So what we have is 1 plus 3 plus our 5 plus dots dots dots. We have our 2k minus 1 plus our 2k. 2 minus 1, it will be plus 1, should be equal to, we have our k squared. So we are going to get plus our k should be equal to, we have our k squared, then we have plus our k, then we have minus our 1. So when you are done with this, what are we going to do? So now you are going to check your original equation. If, remember, this k plus 1 has just been added, this n is equal to k plus 1, you just added it. But try to see by replacing if it's going to give you your k squared plus 2k minus 1. So you can say that checking by substitution, you are going to put your k plus 1, n is equal to k plus 1. In this, where n is, you are going to have your k plus your 1 like that squared. So squaring this, we are going to have this is the same as k plus 1. Then we have our k plus 1 like that. So the first k multiplies everything. So what do we have? We have k multiplying everything. We have k plus 1. Then we have plus our 1 multiplying everything. We have 1 open brackets k plus 1. This is going to give us k by k, it will be k squared. K by 1, it will be k, plus 1 by k, it will be k. This 1 multiplying 1, it will be 1. So that we have k squared plus our 2k, then we have plus 1 like that. So this is what we have. So as you can see, this is the same as what we have here by adding. So that means to say that your, therefore we can say that or rather we can conclude, what was the instruction saying? Mathematical induction for any positive integer n. So we can be able to say, we can conclude that it is true for the formula is true for any integer n, like that. So that's the conclusion. Let's look at our next problem. We have let's say we have our 2 plus our 4 plus our 6 plus our dots dots 2n should be equal to, we have our n open brackets, we have our n plus 1 like that. So now how do you deal with this one? So you are going to begin with the basic step. So the basic step, you are going to let your n be equal to 1 and find out if it is going to give you the first position. So you have, where there is n, you are going to put your 1 open brackets 1 plus 1, which will give you 1 times your 2. So 1 plus 1 is 2. Then after doing that, you are going to find out that this is going to give us a value that is equivalent to 2, which is the same as the number here. So after the basic step, you can say that the formula is true for n is equal to 1. So after doing that, you are going now to go to the inductive step. So the inductive step, you are going to have your inductive step, you are going to say, assuming that it is true for n is equal to k, therefore the equation will become the same thing, which will be which will be your 2 plus 4 plus 6 plus 8. We're just ending plus 6. Then we have plus dots plus your 2n should be equal to, we are going to have where there is so we are taking where there is n, we put k, since we are saying n is equal to k, should be equal to, we are going to put our n there, so we are going to put k there, so we have k plus 1 like that. So after the inductive step, we are going to show that, now we are going to show that it is true for n is equal to k plus 1. So this will be done by adding. So adding means we are going to have the same thing. So we are going to take this equation, 2 plus 4 plus 6 plus dots plus our 2k should be equal to, according to this we have, before equal sign, we are going to add our k plus 2. But just be careful, you are adding it to this part of the equation. So it's 2n. So you take the 2n, where there is n, you are going to put 2, where there is n, you are going to put k plus 1, should be equal to, we have this as the result for, from 2 plus 4 plus 6 plus dots plus 2k, this part is equal to this. So that's why we are going to put our k open brackets k plus 1 like that. So we are adding this on both sides, so we have plus 2 open brackets k plus 1 like that. So this is going to give us 2 plus 4 plus 6 plus dots plus 2k plus 2 by k, it will be 2k plus our 2, which should be equal to, we have k by k, it will be k squared plus k by 1, it will be k, 2 by k, it will be 2k plus 2 by 1, it will be 2 like that. So simplifying this, we are going to get our k squared plus our 3k plus our 2. So now compare if so this is the result for 2 plus 4 plus 6 plus dots 2k plus 2k plus our 2 like that. Compare by substituting. So when you substitute, what are we getting? So we are getting something that is equivalent to substituting n is equal to k plus 1. So if you just take your k is equal to n plus 1, taking just this part of the equation and substituting and see what it will give you. If it gives you the same, it simply means to say whatever you have done there is correct. So you are going to have, where there is n, you are going to put k plus 1 like that. Where there is n, you are going to put k plus 1, but we have another plus 1 like that. So we have our k plus 1, then we have our k plus 1 is 2. This is going to give us, so this k multiplies everything, so we will have k open brackets k plus 2 plus our 1 multiplies everything, that's how we multiply. 1 multiplies everything, so we have k plus 2. So k by k will be k squared, k by 2 it will be 2k plus 1 by k it will be k, 1 by 2 it will be 2. So that we have k squared plus 2k plus k, it will give us 3k plus our 2. So by substituting, we are getting the same answer. So we are getting the same answer. So we are going to say, since it is the same as substituting, the conclusion will be the formula is correct by mathematical induction for any integer n. So this integer n has been mentioned in the question. So basically this is how we are going to be answering mathematical induction questions in this form. So the third one, we have our 1 squared plus our 2 squared plus our 3 squared should be, what do we have? We have plus dot 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 plus our n squared should be equal to, we have our n, which should be equal to n, open brackets, n plus 1, 2n plus 1. Let me move this. Then we have over our value, which is our 6, like that. Then what are we going to do from here? So we are going to begin with our inductive step as usual. So basic step. Let n be equal to 1. So putting n here, we are going to have our, so n, open brackets, n plus 1, 2n plus 1 over 6. This is going to give us, where there is n, we put 1, open brackets, 1 plus 1, open another bracket, we have 2, 1 plus 1 over our 6, like that. So this gives us 1. 1 plus 1 is 2. 2, we have 2 plus 1 is 3. Then we have over 6. So if I multiply my 2 by 3, it will be equal to 6. So we have 6 over our 6, which will give us 1. So this is true. So it is true for n is equal to 1. Remember, this is 1, and the first number showing here is 1. So if we use 2, we could find something like a 5 when we do our math. So here 2 by 2 plus 1, then we have 2, then we have plus our 1, which could still be true if we were to use a 2. It is going to give us a 5 if we use a 2. So if you check this, if you were to check this other number, it will still be true. So if you took this where there is n, you put 2, so it will be 2, open brackets, 2 plus 1 is 3. Then you have 2 times 2 is 4 plus 1, that's 5. Then over 6. So 2 times 3 is 6. 6 times 5 is 30, but we can just say 6 times 5 over the 6. This and this cancels. We are going to remain with a 5. So just a reminder that it will work, but does that mean for every value it will work? We don't know. So that's why we use mathematical induction, because here you can add 5 is coming from the second position plus the first one. So we have a 5 there. So it is true for n is equal to 1. Then here you are going to have inductive step, where you're going to set your n, assume, so you are just assuming that it is true for n is equal to k. That means that you are going to say this whole equation, let me just write it so that I can lift it, 1 squared plus our 2 squared plus our 3 squared plus our dots. Where there is n, you put k squared should be equal to k open brackets k plus 1. Then you have your 2k plus 1 like that. Then you have over your 6 like that. So this is the equation that is required. So with this equation, you are going to put it here. So after you put the equation here, you are going to, so for the inductive step, that's the only thing you are doing. So after you do that with the inductive step, you are now going to go to the inductive hypothesis by advancing it for the next term. So is the formula true for the next term? So you are going to say the inductive hypothesis. So under the inductive hypothesis, you are going to say, show that it is true for n is equal to k plus 1. So n is equal to k plus 1 means that we are going to have, so by adding this term, we are going to have, so this term still sticks. We have our 1 squared plus 2 squared plus our 3 squared plus our dots. We have our plus our k squared like that. Then adding the next term means where there is n in the original equation, which was saying, so as you can see here, where it says k, you are going to put your k plus 1. So it will be plus your k plus 1. But there is a squared outside for where n is. So you are going to add this result to both sides. So this should be equal to, we have, so as you can see, 1 squared plus 2 squared plus 3 squared plus dots plus k squared is here, which is equal to, they are telling you that it's exactly the same as this one. So we write this, let me just lift it. So after you write this, you are going to put it this side. After you put it this side, what are we going to have? So after we do that, okay, so after doing that, we are going to put plus our k plus 1 squared like that. And then just multiply. We are going to have our 6 is common. Then we have our k open brackets k plus 1. Then we have our 2k plus 1. Then we have, if 6 divided by 1 is 6 times this, it will be plus 6. Then in the brackets, it will be equal to, what are we going to have? We are going to have open brackets, we have our k plus our 1 squared like that. So this is what we have, but let's simplify. So k by k is k squared, k by 1 it will be plus k. Okay, which one is the easiest way? Okay, let's find the easiest way of doing this. Let's first factorize. K plus 1 is common, k plus 1 is common, so we are going to say k plus 1 like that. Then what are we remaining with? We are remaining with our k. Then the other remaining thing is our 2k plus 1 like that. Then we have plus our 6. Then k plus 1 squared. So now we are going to have k plus our 1 like that. Then over our 6 like that. So what are we going to have? We have our k plus 1 like that. Then let's simplify. We have 2 by k. It will be 2k squared. Then we have k by 1. We are going to have plus our k. 6 by k, it will be 6k. Then we have plus our 6 by 1 is 6. Then we divide this by our 6. So what are we going to have when we do that? So after doing that, we are going to have our k plus 1. Then we have our 2k squared. Then k plus k squared, or k plus 6k will be 7k. Then we have plus our 6 like that. Then we have over our 6 like that. So this being a quadratic equation, you can factorize it. So if you factorize your 2k squared, so factorizing your 2k squared plus your 7k plus 6, this will be equal to, we have the product should be equal to AC, which should be equal to, A is this, C, we have B. AC will be equal to 2 by 6, which will be equal to 12 like that. So if that is our 12, then we are going to have our sum, which should be equal to B, should be equal to, the coefficient there is 7. Then our factors, two numbers, which when we add them, they give us 7. We multiply them, they give us 12, are 3 and 4. So we are going to put this. So we have our 2k squared plus our 7k, or where there is 7, we put these values. We have 3 plus 3, but we are attached k, plus our 4, we attach k, so that 3 plus 4 gives us 7. Then we have plus our 6. So this is going to give us, factorize in parts. So we have k is common, so we put k, open brackets, we're remaining with a 2, 1k plus our 3 like that. Then here 2 is common, so we are going to say 2, open brackets, 4 divided by 2 is 2k, then we have plus our 3 like that. So our 2k plus our 3 is common like that, so we take them in one bracket, then we have our k plus our 2 like that. So this is the factorized form for this equation. So taking this equation, we are going to have our k plus 1, then we also have our 2k plus 3, which we have found, and our k plus our 2 like that. Then all of this is over 6. All of this is over 6. So this is what we have. So everything, it is equal to that. We are adding, so this equal sign means this number is still there. That's the meaning, but we cannot keep writing it, so that's why we are putting equal sign here. So if that is the case, that means to say we are going to compare by substituting n is equal to k plus 1 in the original equation. So the original equation is this, where it says our n plus our n, open brackets, n plus 1, 2n plus 1, then we have our over our 6 like that. Then we have the value that is equivalent to, we have you are going to replace this value. Remember, you did not get this value by replacing in the first place. I'm talking about this one. You didn't get it by replacing. So if you get the same by replacing, it means to say the formula is correct by mathematical induction. So we are going to have, where there is n, we put k plus 1. Then where there is n here, we put k plus 1, but there is another plus 1. Then we have our 2, where there is n, we put k plus 1. Then we have plus our 1 like that. Then over the 6 like that. So this gives us our k plus 1. Then we have k plus 1 plus 1 is 2 like that. Then we have 2 by k, it will be 2k, plus 2 by 1, it will be 2. Then we have plus 1 like that. Then this thing over our 6 like that. So this means that we have our k plus 1. Then we have our k plus 2. 2. Then here we are going to have 2k plus 2 plus 1, that will be a 3, then we have over our 6 like that. So this is what we have gotten, and this is what we got. So as you can see, they are exactly the same. So we are going to say, so the conclusion, or we can say, since adding and substituting n is equal to k plus 1, the conclusion will be it is true by mathematical induction. The next one, the formula is true by mathematical induction. The next one that we are going to have is, we are going to get our next question. By now you should be conversant on how we are doing things. We already have one here. Okay, yeah, let's just use this one. So taking this other equation, what are we going to do? So we have our 1 dot 2, dot means multiplication, plus 2 dot 3 plus 3 dot 4 plus our plus our 2, n should be equal to n plus n, open brackets, our k, n plus 1. So we are going to say by basic step, you are going to let your n be equal to 1 so that you replace there. So we have our n, it is, for n is n open brackets n plus 1, we are going to have 1 open brackets 1 plus 1, which will give us 1 by our 2, which will be 2 by 1, it will be a 2 like that. So if it has given us our 2, that means that 2 is the same as here, because 1 dot 2 is 1 times 2, which will give you 2. So it is true for n is equal to 1, like that. Then you are going to go for inductive step. For the inductive step, what are we going to have? So inductive step, we are going to let our n be equal to k, like that. So this gives us a value that is equivalent to, we are going to replace everything by, let us put it here. So we are going to replace, we have 1 dot 2 plus 2 dot 3 plus 3 dot 4 plus our dots plus our 2. Where there is n, we are saying that n is equal to k. Where there is n, we put k should be equal to, where there is n, we put k, like that. Then open brackets k plus our 1, like that. Then we are going to say, finally we are going to say the inductive. So remember, assume that it is true for n is equal to k, which k can represent any number. Then we are going to go for inductive hypothesis. So the inductive hypothesis, we are going to take n is equal to this by adding. So when you do that, what are we going to have? We have 1 dot 2 plus 2 dot 3 plus our 3 dot 4. Then we have plus our dots. We have our plus our 2k plus. Now this k plus 1, it will be our 2, because where there is n, it's 2. Then where there is n, we replace our open brackets k plus 1 should be equal to, so whatever you replace, you add on both sides. We are going to have we already have this, so we are going to write it. So we have our k plus k open brackets. Let's reduce the font. Hope you can see k open brackets k plus our 1. Then we are going to have plus. Where there is a k, you are going to put the result for this, which will be 2 by k. It will be 2k plus 2 by 1. It will be 2. So that is what we are going to put, 2k plus 2, like that. So with this done, what are we going to do? So we are going now to equate. So we have k by k, it will be our k squared, like that, plus k by 1, it will be k plus our 2k plus our 2, like that. So this gives us our k squared plus k by this, it will be 3k plus our 2, like that. Now we are going to comparing by substitution. So taking just the end of the equation, which is your n, open brackets n plus 1, this is going to give us a value that will be equal to our n, open brackets n plus 1. This gives us n is equal to, comparing by substituting k plus 1, where there is n, we are going to say k plus 1. Then we have, where there is n, we say k plus our 1 plus our 1. This is going to give us k plus 1 and our k plus our 2. So expanding this, it will be equal to, we have our k multiplies everything, so we have our k plus 2 plus our 1 multiplies everything, we have k plus our 2, like that. K by k, it will be k squared, plus k by 2, it will be 2k, plus 1 by k, it will be k, 1 by 2, it will be 2, which will give us k squared plus this, it will be 3k plus our 2. So as required. So since adding and substituting, gives the same result, so these statements are important. We can say, therefore, the conclusion will be the formula is correct by mathematical induction. The next one, for number 4, we have done this, so we are on number 5. With all these questions, there's nothing that you can fail. So we have 1 over 1.2 plus 1 over 2.3 plus 1 over 3.4 plus 1 over n open brackets n plus 1 should be equal to n over n plus 1, like that. So how do you do this one? So how you do this one, same basic step. Let your n be equal to 1. This gives you, where there is n, for n over n plus 1, this gives you 1 over 1 plus 1, which will be equal to 1 over 2, like that. Inductive step gives you, we are going to let, or rather assume, that it is true for n is equal to k. So after doing that, we are going to replace in the original equation. So let me just grab it. So we have 1 over our 1 dot our 2, like that, plus just the same equation. Where there is n, we are going to put k, even here, k like that. Then the inductive hypothesis, let's show that it is true for n is equal to k plus 1. So this is done by adding. That means if we write this first, after we write this, we add an extra number now. So we are going to make it a bit small. Then we add plus our 1 over, where there is n. Remember, we are taking from the original equation. It's saying n, where there is n, we are going to take our k plus 1. And where there is n, we take k plus 1. K plus 1, but there is an extra one like that. So that means to say we are going to have our k plus 1. We have, as we have written, open brackets, k plus 1, but there is another one like that. So this should be able to give us, remember, we already have this, so we are going to just lift it. We are going to lift it like that. When we lift it like that, put it there, then add plus our, which one are we adding? We are adding this, which is our 1 over, we have our k plus 1, then we have k, 1 plus 1 is 2, so we have our k plus our 2 like that. So after you do this, find the common denominator, which will be equal to, let's do this, k plus 1 is common. What else is common? Let's take k plus 1 and our k plus 2 as our common denominator. So that means to say, if we take our this divided by k plus 1, it will be equal to, we have our k multiplied by this one, which will be our k plus our 2. Because when you divide this, what we have is, when you take k plus 1 by k plus 2 divided by this number, it means to say, if we divide by our k plus 1, this and this will cancel to give us k plus 2 like that. So if that's the case, we have our k plus 2, we have our k plus 2, then we have plus, this divided by this is 1. Then we are going to have our k plus 1, or k times k, it will be k squared, plus k by 2, it will be our 2, it will be our 2 k plus our 1 over our k plus 1. Then we have our k plus 2. So factorize this. Factorizing this will be k squared plus so factorizing our k squared plus our 2k plus 1, this gives us, long story short, so factorizing this will be k plus 1, which will be our k plus 1 by our k plus 1. So I've just factorized it very fast. You know how to factorize by now. So after that, we are going to replace it here. So this is going to give us k plus 1, open brackets, k plus 1, like that. Then what do we have here? We have our over k plus 1, then times our k plus 2. So this and this cancel. So we are going to have our k plus 1 over our k plus our 2. So this is what it is giving us. So that whole equation, which was saying that we have our 1 over 1.2 plus 1 over 2.3 plus 1 over 3.4 plus our 1 over, is it dot plus our 1 over, we have our k, open brackets, k plus 1 by plus our next term, which is 1 over 1 plus this and 1 plus that will be equal to this. So I've just written this equation. 1 plus 1 is 2, like that. So comparing by substituting, if it does not, it means to say it is not it is not correct by mathematical induction, but most of the times it will be correct. So if it is not giving you the same thing, it means to say you might have made a mistake somewhere. So we have, when we do this, we're going to say n is equal to k plus 1, and the end goal, it is saying that we have our n, we take this, it is saying that we have our n, which will be equal to k plus 1, like that, where we have n over, where we have n we put k plus 1, then we have plus 1, k plus 1 over k plus our 2, like that. So if this is the case, this is what we have. So as you can see, this is the same as this. Where is it? The final answer, which is here. Therefore, we can say, since it is true for substituting, or rather, since it is equal for substituting and adding, our conclusion will be that it is true by mathematical induction. Our final question for this video is this question. Let's take this first. We have our 1 cubed plus our 3 cubed plus our 5 cubed plus our ... 2n minus 1 to the power 3 should be equal to n squared. Then we have our 2n squared minus our 1. So what are we going to have for this problem? So under this problem, we are going to have basic step. Let your n be equal to 1. 1 is much easier to deal with. So let your n be equal to 1, like that. This gives us a value that is equivalent to 1 cubed plus, we take the n squared, open brackets, 2n squared minus our 1. So where n is equal to 1, we say 1 squared, open brackets, 2. Where n is, we have 1 to the power of 2 minus 1, which will be 1 times 2 by 1, it is 2 minus 1, like that. So we have 1 by 2 minus 1 is 1, which will just be equal to 1. So as you can see, 1 is equal to this one here. So we are going to say it is, or rather, the formula is true for n is equal to 1. Inductive step, our n is equal to, we are going to assume that it is true for n is equal to k. That's the inductive step. That means to say we are going to write our 1 to the power 3 plus our 3 to the power 3 plus our 5 to the power 3 plus dots dots dots. We have 2n minus 1 to the power 3. So where there is n, we put k. So we have 2k minus, should be equal to k squared. Then we have our 2k squared minus 1. Inductive. Finally, when you reach there, we are going to say inductive hypothesis. We are going to prove that it is true for n is equal to k plus 1. So by adding, we are going to have our 1 cubed plus, we have our 3 squared plus our 5 to the power 3 plus dots dots dots. We have our 2k plus 1 to the power 3, add plus this k plus 1, but you are going to substitute. You have where there is here where there is n, you are going to put k plus 1. So we have plus our, why is it okay, it's okay like that. So here it's minus. Why have I written positive? So we write our negative there, so we have minus 1. So we are going to have 2. Where n is, we are going to put k plus 1. So we have k plus 1, then we have minus 1, then outside there is the power 3 like that. So this should be equal to, we are going to have, so we are going to have our value, which is equivalent to, we have our k squared, open brackets, 2k minus 2k squared minus 1 like that. So after doing this, what do we have? We have plus this value, which will be our 2, open brackets, we have k plus 1 minus 1 to the power of 3 like that. So let's deal with this side. We have our k squared, 2k squared minus 1 plus, we have open brackets, 2 by k it will be 2k, 2 by 1 it will be plus 2, then we have minus 1 to the power of 3 like that. So this gives us k squared, open brackets, 2k squared minus 1, then we have plus, open brackets, 2k, then we have 2 minus 1, it will be 1, then we have power 3. From here, let us be able to expand. Let's expand. So we have k by 2k squared, it will be 2k to the power 4. This by this, it will be minus k squared, then we have plus. So this is the same as having 2k plus 1 times 2k plus 1, then finally it is the power 3. So that means to say we are going to have another 2k plus 1. So we can expand in parts. So we have 2k to the power of 4 minus k squared, then we have plus this 2k multiplies everything, so we have our 2k like that plus 1. So let's just deal with this first. This second number multiplies everything, so we have plus 1, 2k plus 1 like that. Then all this is again being multiplied by 2k plus 1 like that. So this gives us our 2k to the power 4 minus k squared, then we have plus 2k by 2k, it will be 4k squared. 2k by 1, it will be plus 2k. Then we have plus 1 by 2k, it will be 2k. 1 by 1, it will be 1, like that. Then we have our 2k plus 1, like that. So this gives us 2k to the power 4 minus k squared plus, what do we have? We have 4k squared. 2k by 2 plus 2k, it will be 4k. Then we have plus 1. Multiply again with our 2k plus 1. So how do you multiply? You can use the binomial theorem if you want, whichever, minus k squared. So this 2 multiplies everything, so this gives us 2k multiplies everything, so we have 4k squared plus 4k. Then we have plus 1, then plus our 1 again multiplies everything. Let me move this and reduce it a bit. So our 1 multiplies everything, that is here, so we have 4k squared plus our 4k plus our 1, like that. So after doing this, what does it give us? So we have 2k to the power 4 minus k squared plus our 2k by 4k squared, it will be 8k to the power of 3. This by this, it will be equal to plus our 8k to the power of 2. This 2 by 1, it will be plus our 2k, like that. So after doing that, we have plus 1 by k, it will be 4k squared plus 1 by 4k, it will be 4k. Then we have plus 1 by 1, it will be 1, like that. So this gives us 2k to the power 4 negative k squared plus our 8k squared. So this and this, if you add this, what are you going to get? Okay, I hope there's no mistake. We have no, so this is not a part of it. We are trying to add those that have squares, so this and this term only. So what are we going to have? First, let's write the next one is 8k to the power 3. So we write it 8k to the power 3 plus the next one is 8k plus 4k is 12 minus k, it will be 11k squared. Then we deal with the ones with just k. So this will give us 6. So we are going to say plus 6k. Then we have plus 1. So this is what we have. So now let's comparing by substitution. By substitution, what are we going to have? So we are going to take this end, which is your n squared, 2n squared minus 1. So if we take this value and say our n is equal to k plus 1 is what we are substituting. So we have k plus 1, then we have power 2. So we have power 2, open brackets 2, k plus 1, power 2 minus our 1, like that. So this gives us a value that is equivalent to, we have, if I expand this, it will be k plus 1, k plus 1, that's the meaning of the square. Then in brackets it will be k plus 1 squared. Then here it will be the same. We have our 2, open brackets, k plus 1, and our k plus 1. Then we have minus 1, like that. Is there any power on this one? So there's no power there. So this is what we have. So let's just expand. So this k multiplies everything. So we have our k plus 1. So the first number multiplies everything, plus the second number multiplies everything. So we have k plus 1. This gives us k by k is k squared plus k by 1 it's k. 1 by k it will be k, 1 by 1 it will be 1, which will be k squared plus k is 2k plus 1, like that. So this is what we are going to have for anywhere we see something like this. So we are going to put it. So here we are going to say k squared plus 2k plus 1. Then we have our 2. Remember, we are still multiplying k plus 1, so we are going to have our k squared plus our 2k plus our 1, like that. Then we have minus our 1. So this gives us k squared plus 2k plus 1 multiplied by, we have 2 by k it will be 2k squared, 2 by 2 it will be 4k, then we have plus 2 by 1 it will be 2, then we have minus 1. So we are multiplying the same things, k squared plus 2k plus 1. Then we have 2k squared plus 4k. 2 minus 1 is our 1, like that. Okay, so let's multiply properly. So the first thing that we are doing, okay, let's do this. We have our k squared multiplies everything here, so we are going to have 2k squared plus 4k plus 1. Then this number now multiplies everything that is here, so we are going to have plus 2k, open brackets, 2k squared plus our 4k plus our 1. Then we have plus our final value is 1, open brackets, we have our 2k squared plus our 4k, then we have plus our 1. So this gives us k by 2k squared. This will give us a value that will be equivalent to 2k to the power 4. This by this will give us 4k to the power 3 plus this and this will give us k squared plus this and this will give us 4k to the power 3 plus this and this will give us 8k, like that, squared. This and this will give us our 2k, like that. So with that said, we are going to have a value that will be equivalent to plus this by this will be 2k squared plus this by this will give us 4k plus this by this will give us 1. So we have, when we add, we are going to have 2k to the power 4. Then these two have got the same power, so we add this and this. This is going to give us 8k to the power 3. Then we have this, adding this and this and this, we are going to have, so those are the only terms. So 8 plus 2 is 10 plus k squared, it will be 11k squared, like that. Then plus our 2k plus our 4k, it will be 6k. Then we have plus our 1, like that. So as you can see, this number is exactly the same as this number. So therefore we can say that since adding and subtracting gives are equal, then that simply means to say the conclusion will be that the formula is correct by mathematical induction. So that is how we solve that. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.